Good morning. Today's lesson is all about another way of writing the equation of a line. So the last two lessons we looked at the slope-intercept form, which remember is y equals mx plus b. And remember we said that's a really good way to write the equation of a line because it gives you information just by looking. It tells you what the slope is, and it also gives you the y-intercept. Okay, so no mess, no fuss. All you got to do is look, and you've got that those two important points. And remember that with those two important points, you can then go ahead and graft a line. So that's why it's very useful. What we're going to look at today is simply a rearrangement of the slope-intercept form. It's called the general form of the equation of a line. Now, this definition is extremely mathy and somewhat difficult to make sense of, but basically what it means is if you take the equation in slope-intercept form and you rearrange it so that everything is moved over to the left side. So everything to one side. Okay. A second thing that all lines in general form have in common is no fractions and the coefficient or the number attached to your x variable, your first variable. The coefficient of x is positive. And we'll discover how you can manipulate your equation to get those last two things, no fractions and coefficient of x is positive. It's very straightforward, okay? So what we're going to be doing today is just a lot of rearranging, and you'll recall that at the beginning of this chapter I mentioned that rearranging equations is really important. Okay, you've got to get to the point where you can just do that in your sleep. Okay, just to make sure we're all on the same page. In the module that you're working on, the general form is lesson 7.2. Okay, so let's just do a little bit of rearranging. Okay, so for the first one, it says rewrite the following equations in the general form ax plus by plus c equals 0. Now remember, a, b, and c are just numbers. Okay? They all have to be non-fractions, and this number a, the one attached to the x variable, has to be positive. Okay, so keep that in mind. We'll do a couple of examples. First we'll do an easy one, and then we'll work on some somewhat nastier ones that have things like fractions and decimals. But if we want to rearrange this to get everything to one side, the easiest way to do it, because you only have the one term on the left, is we're going to move everything over to the right side. It doesn't matter if you move everything to the right or everything to the left, so long as everything is on one side. Okay? So if we want to get rid of this y, in other words, we want to move it over to the right side, we simply subtract y from both sides. Y minus y gives us 0, which is what you want to have on one side. And here, since there are no like terms we can combine this y with, we just write it like that. Okay? Try and get into the habit of writing the x variable term first, the y variable term second, and the constant term, that is the term that has no variable attached, or your c term, last. That's it. We're done. Okay? That was pretty easy. Now, of course, it was pretty easy because we didn't have any fractions. Our number or coefficient attached to the x was already positive, so there wasn't much to do. Okay? This one is a little more difficult. Okay, so first of all, let's move everything over to one side. Okay, so again, just like with the first example, we simply subtract y from both sides, and what that gives us is 0 on the left side, right? Y minus y is 0, equals 3/4 x minus y minus 1. Okay? So, again, go through your checklist. Is everything on one side? Yep. No fractions? Uh-oh, there's a fraction here. We're going to have to deal with that. Is the coefficient of x positive? Yeah, it is. 3/4 is a positive number. Okay? We have to get rid of this fraction. In order to get rid of fractions, you simply multiply by the lowest common denominator. Okay? Now, in this case, there's only one denominator, so if we multiply everything through by 4, look what happens. Okay? So we're going to take our equation, we're going to multiply everything by 4, and that's perfectly fine as long as you multiply every term by 4, you will still have an equivalent equation. Okay? So look what happens. Remember, we have to distribute the 4 over every term in the brackets. So 4 times 0, 4 times 3/4, 4 times 1, and 4 times 1. Okay? 4 times 0, well, anything times 0 is just 0. 4 times 3 over 4 will give us 12 over 4, right? 4 times 3 is 12. X. 4 times 1 will give us minus 4y. And again, 4 times 1 gives us minus 4. Now, you might say, well, I didn't do anything. I still have a fraction. But look what happens. Your fraction has now become a fraction that can be simplified to a whole number, right? 12 divided by 4 is 3. And what we've done is we've gotten rid of the fraction. So now everything is on one side, we don't have any fractions, and our coefficient of x is positive. Okay? Let's try another one. We'll go way up. So here's another equation in y equals mx plus b form. Remember, general form is ax plus by plus c equals 0. Okay? Oh, let's just adjust a little. There we go. Okay, so we want to take it from this form and turn it into this form. Okay, so step 1, move everything to one side. And again, the easiest way to do that is just to subtract y from both sides. Y minus y will give us 0. And on the right side, we'll have negative 2/5 x minus y plus 3. Now we're left with an equation where we have two problems. Okay, we have the problem we had in our last one, which is we have a fraction. But we have a second problem, and that is the coefficient of x, the number attached to our x variable, is a negative number. We got to make it positive. That's easy. Okay? So, to deal with the fraction, remember, we multiply through by the least common denominator. And again, that's 5. So we're going to multiply everything by 5. And this time, in order to get rid of that negative sign on the fraction, if we multiply everything through by negative 5, then look what happens. Negative 5 times 0 will give us, and I'll just put it down here, negative 5 times 0 again gives us 0. Negative 5 times negative 2 over 5 will give us positive, remember, negative times negative will give us a positive 10 over 5 x, right? Negative 5 times negative 2 is positive 10. Negative 5 times minus 1 will give us plus 5y, and negative 5 times positive or plus 3, positive times negative will give us negative 15. Okay? We've distributed the negative 5 over every term inside the brackets. Remember, always every single term. Okay? Now you'll notice again, the fractional part will simplify into a nice whole number, right? 10 divided by 5 is 2, x plus 5, y minus 15. And you have a general form. Okay? We're going to do one more. This time we're going to deal with decimals. Remember, well, we'll deal with this decimal. Just let me get this out of the way. Okay, step 1, move everything to one side. So we subtract y from both sides. Y minus y is 0, and we end up with 0.5x minus y minus 0.4. Now this time, it's not a fraction, it's a decimal. We need to have a whole number, okay? So, the easiest way to do that is, if you think about it, if we multiply by a power of 10, either 10 or 100 or 1,000, all we'll be doing is moving the decimal here. So in other words, if we take this equation and multiply it by 10, that is, we multiply every term by 10, then we'll get 10 times 0 is 0, 10 times 0.5 is just 5. 10 times minus 1 is minus 10y. 10 times 0.4 will be minus 4. Okay, I've mentioned this often in the measurement chapter, but that's the nice thing about dealing with powers of 10, right? You're just moving the decimal back and forth. So, again, we end up with an equation that's in general form, right? Everything to one side, no fractions or decimals, and the number attached to x is positive. Okay? A quick review. X and y intercepts. Now remember, we talked about this in a previous lesson, so I'm going to go through it very quickly. Remember, the x-intercept is simply, remember this is the x, this is the y. The x-intercept would be where the line crosses the x-axis. The y-intercept is where the line crosses the y-axis. Okay? The value of x when y equals 0 is just another way of thinking of the x-intercept, because remember, at this x-intercept, we may not know the x value, but we know for sure, always and forever, for the x-intercept, the y-coordinate will be 0. Similarly, for the y-intercept, we may not know where it crosses the y-axis yet, but we know that the x-coordinate of that will always be 0. Okay? So just remember it's kind of the opposite. For the y-intercept, the x-coordinate is 0. For the x-intercept, the y-coordinate is 0. Okay? Now, we did this in the last lesson as well. If you want to determine the x-intercept of an equation, you simply substitute y equals 0 and solve for x. If you want to determine the y-intercept, you do the opposite. You sub in x equals 0 and solve for y. Okay? So we're going to do one more example of that. Now, in order to figure out the coordinates of the x and y intercept, it doesn't matter if your equation is in general form, as this one is, or in slope-intercept form, as this one is. Okay? Now, we'll do this one. Okay? So let's find the x and y intercepts. So for the x-intercept over here, for the y-intercept right here. Now remember, if you're looking for the x-intercept, you want to substitute a value of 0 for your y-coordinate. So your equation, y equals negative 4x plus 8, will become 0 equals negative 4x plus 8. I've simply substituted a value of 0 for y, and then simplify the right side. 0 equals negative 4x minus 8, it's already as simplified as it can be. We want to isolate the variable. That means we have to get rid of the 8, and we have to get rid of the negative 4. Remember, always move stuff that involves adding and subtracting before you move stuff involving multiplying and dividing. So, we want to get rid of this 8. That's easy. Subtract 8 from both sides. That gives us negative 8 equals negative 4x. Then we want to get rid of this negative 4 because it's multiplied. When we get rid of it, we're going to have to divide by what we're trying to get rid of. So we're going to divide both sides by negative 4. Negative 4 divided by negative 4 is 1. So that leaves us with 1x. Negative 8 divided by 4 is 2. So in this case, our x-intercept equals 2. Okay? And the coordinates of the point at that x-intercept will be 2, where it crosses the x-axis, and 0, remember we said the y-coordinate will always be 0 at the x-intercept. Let's take a look at the y-intercept then. We're going to take our equation, and this time instead of substituting 0 for y, we're going to substitute 0 for x, giving us y equals negative 4 times 0 plus 8. Okay? This one simplifies really easily, because we know that negative 4 times 0 is 0. That will simply leave us with y equals 8, and we're already done. Okay? So, this would be a line that crosses the y-intercept at 8 and the x-intercept at, or the x-axis, at 2. Okay? Giving us a line that would have a very steep slope, and since it slopes down to the right, we know that slope will be negative. And if you take a look at the slope of our original equation, that's true, right? It has a negative slope, and 4 is a very steep slope as well. Okay? So that's general form. We'll do a couple of examples. I think we'll skip this because it's just determining x and y intercepts again, and you'll get plenty of practice on that. Special cases. Intercepts of horizontal and vertical lines. Very, very easy. Okay? If you don't think about it too much. So, here we have an equation in general form. The first thing you should notice here is there is no x term. So if you have a horizontal line, you will find that in most cases there's no x term. So, step one, rewrite in slope-intercept form and use it to state the slope and y-intercept. So remember, slope-intercept form was what we worked on in the last two lessons. Slope-intercept form is y equals mx plus b. So we take our y minus 4 equals 0, and we want to isolate y, right? We want to get y all alone. Well, that's easy. Just add 4 to both sides, and we get y equals 4. Now, your first question when you try to figure out what the slope is, well, wait a minute. The slope is supposed to be the number that's attached to my x variable. Well, this one doesn't have an x variable. Okay? If you come up with an equation like that, where there's no x variable, that simply means you have no slope. Okay? So no x variable means no slope. And if you have no slope, that simply means you have a slope of 0. Okay? What's your y-intercept? Well, again, remember we said that's why we like this form of the equation so much, because it tells you what the y-intercept is. The y-intercept is this number here that's all by itself. The y-intercept is 4. Okay? So what does that tell us? That tells us we have a line with a y-intercept of 4 and a slope of 0. And you'll remember from the lesson on slope, if you have a slope of 0, that is nothing particularly weird. It simply means you have a perfectly horizontal line. Okay? So the equation of this line would simply be y equals 4. Okay? Notice that it's telling you that you have a line with no x variable, meaning a flat slope, that crosses with a y-intercept of 4. Okay? So, rewrite this equation as y equals 4 by solving for y. This equation indicates that every point on the line has a y-coordinate of, well, think about it, this point, this point, this point. The coordinates for this point are -5 and 4. How about this point? The coordinates for this point are -3 and 4. This point we've already talked about. It has coordinates of 0 and 4, right? That's the y-intercept. This point here has coordinates of 2 and 4. So what can you say about every single point on this horizontal line? Every single point on this horizontal line has a y-coordinate of 4. Okay? And the same holds for any horizontal line. All y-coordinates will be the same. Okay? Okay, so let's try this one. So, what we looked at just previously was horizontal lines. Now we're going to look at vertical lines. Okay? So given 2x plus 4 equals 0, first thing you should notice, this one is different from our last one, and I'll just write our last one here. Whereas this equation has no y term, this equation had no x term. Okay? So both of them are missing a term. It's just it's a different one. And we discovered then that when it was missing the x term, that meant that the slope was 0, and it meant we got a horizontal line. Here, we're going to rewrite this equation by isolating x. So that will give us, I'll just do it over here, 2x plus 4 equals 0. We want to isolate x, so we'll get rid of stuff that involves adding and subtracting first. 4 minus 4 is 0, giving us 2x equals negative 4. Then we'll get rid of the 2, which, because it's attached to the x through multiplication, to undo it, we have to do the opposite. We have to divide. 2 divided by 2 leaves us with 1x. Negative 4 divided by 2 leaves us with negative 2. And our equation becomes x equals negative 2. This equation indicates that every point on the line has an x coordinate of, just as we found in the last one, every point had a y coordinate of 4. In this case, every point will have an x coordinate of negative 2. Okay? Graph the line. Well, if every point has an x coordinate of negative 2, then that means we're dealing with points that line up like this. We have an x-intercept at negative 2, and that will result in a perfectly vertical line. Now, what's the slope of this line? We haven't talked about that. Okay? The slope of this line, being as it's a vertical line, slope is undefined. Okay? So the slope of a vertical line is undefined. Graph the line, we did. State the domain and range. Well, our domain is our x values. So our domain is really easy. X values such that x equals negative 2. There's no other values for x, right? Since we have a solid line, we can say x is an element of the set of reals. How about our range? Our range is our y values, and since this line can go on forever, both up and down, we can say that y has to be greater than negative infinity or less than positive infinity, and y is an element of the set of real numbers, again, because we have a solid line. There's a much easier way to write this. If y can essentially be any number, right? It's between negative and positive infinity. We can simply say y can be any real number, right? Because it goes from negative infinity all the way up to positive infinity. Okay? I won't ask if you have any questions, because I can't hear you if you do. But that brings us to the end of the lesson. Tomorrow we'll complete this lesson on general form, give you a little bit of review. Again, we'll let this sink in a wee bit, and that's it for today. Have a lovely day, and we'll see you in the next lesson.